Hi everyone. Today I'm going to introduce a programming language class in GIST, Gwangju Institute of Science and Technology. The class title is Programming Language and Compilers, and the course number is EC 3204. We have 3 hours of classes a week, and my name is Jin-seok Gong. Before talking about high-level programming language, I would like to look at machine language first. This slide shows 2 programs written in machine language that calculate the greatest common divisor GCD of 2 integers. They were expressed as hexadecimal numbers for both x86 and MIPS machines. Machine language is the sequence of bits that directly controls a computer processor, causing it to add, compare, move data from one place to another, and so forth. Machine language was created and used when the first electronic computer were invented in 1940s. Writing programs at this level of detail is an enormous, tedious task. As people began to write larger programs, it quickly became apparent that a less error-prone notation was required. Thus, assembly language was invented to allow operation to be expressed with mnemonic abbreviations. The GCD programs written in assembly language are shown in the lower left corner of the slide. Assembly languages were originally designed with a one-to-one correspondence between mnemonics and machine language instructions. The first mnemonic corresponds to the first machine instruction, and the second one corresponds to the second instruction, and so on. A systems program, known as an assembler, translates from mnemonics to machine language. However, programming continues to be machine-centric. Each different kind of computer has to be programmed in its own assembly language. An x86 computer needs x86 assembly language, and a MIPS computer needs MIPS assembly language. Programmers thought in terms of machine instructions that computer actually execute. As computers evolved, it became increasingly frustrating to have to rewrite programs for every new machine. It also became increasingly difficult for human beings to keep track of the wealth of detail in large assembly language programs. People began to wish for a machine-independent language. People particularly wanted numerical computations to be expressed in something more closely resembling mathematical formula. These wishes led in the mid-1950s to the development of a Fortran-like language, the first high-level programming language. A Fortran program for GCD is shown in the first part of the high-level programming language examples. Today, there are thousands of high-level programming languages, and new ones continue to emerge. Some of them, C, OCaml, and Prolog, are shown in the last part of the high-level language examples. A systems program known as a compiler translates from a high-level language to machine language. Compilers are substantially more complicated than assemblers because the one-to-one correspondence between source and the target operation no longer exists. As you can see in the previous examples, programming languages may differ significantly in syntax and semantics. However, they share many common design concepts, translation mechanisms, and properties. This course reviews the common features among programming languages, defines programming language classes, introduce imperative, functional, and logic programming language concepts, and also present theoretical and pragmatic aspects of programming language design, implementation, and analysis. Thus, students will be able to understand fundamental principles of design and implementation of programming languages. This is a brief explanation of this programming language class. Thank you.